In October 19, 2017, astronomers at the Pan-STARRS. One telescope in Hawaii made a discovery that would forever change our understanding of the cosmos. As they scanned the night sky, they noticed a faint speck of light, barely visible, moving in a way that defied all expectations and immediately caught their attention. This was no ordinary asteroid or comet, it was something truly extraordinary. Unlike anything previously observed in our solar system, this mysterious object was traveling on a hyperbolic trajectory, meaning it was not bound by the sun's gravity. This was a clear and unmistakable sign that it had come from far beyond our solar neighborhood, originating in the vastness of interstellar space. The object was given the name Oumuamua, which in Hawaiian means, a messenger from afar arriving first. The name itself reflected the sense of wonder and curiosity that swept through the scientific community. For the very first time in human history, we had confirmed the presence of a visitor from another star system. A true interstellar traveler passing through our cosmic backyard. The discovery sent shockwaves through the scientific community, electrifying astronomers and space enthusiasts alike. It opened a brand new window onto the universe, hinting at the possibility of countless other objects traveling between the stars. Urgent questions immediately followed. What was this object made of? Was it a chunk of rock, a fragment of ice, or something entirely unknown to science? Where exactly did it come from? Which distant star system had launched this cosmic messenger on its long journey across the galaxy? How long had it been traveling through the emptiness of space before finally reaching us? Was it wandering for millions, or even billions of years before this chance encounter? Telescopes around the world sprang into action, racing against time to observe Oumuamua before it slipped away forever, vanishing into the darkness of space. Already speeding out of the solar system at an incredible velocity, Oumuamua would soon become too faint and distant to study in detail. The window of opportunity was closing fast. This was our one and only chance to examine an interstellar messenger up close, to gather as much information as possible before it disappeared forever. Every second of observation was precious. Scientists worked around the clock, coordinating efforts across continents to capture every possible detail. The universe had sent us a message in the form of this enigmatic visitor, and humanity was desperate to decipher its secrets before it was gone. Oumuamua's brief and mysterious visit would ignite one of the greatest astronomical mysteries of our time, inspiring new questions about our place in the cosmos and what else might be out there, waiting to be discovered. As astronomers tracked Oumuamua, they noticed something strange, something that set it apart from every other object they'd ever observed passing through our solar system. As it moved away from the sun, Oumuamua began to accelerate, gaining a tiny but persistent push that defied expectations. This wasn't just a minor detail, it was a behavior that demanded explanation. Normally only comets accelerate this way, propelled by jets of gas from sublimating ice as they heat up near the sun. These jets act like natural rocket engines, giving comets their characteristic tails and a visible boost in speed, but Oumuamua showed no visible tail, no glowing coma, and no sign of outgassing at all. It was moving through space in complete silence, with none of the usual cometary fireworks. Even the most powerful telescopes, including Hubble, found nothing, no dust, no gas, just a silent traveler slipping through the darkness. The object left no trace, no evidence of the forces that seemed to be acting on it. The object was accelerating like a comet but looked nothing like one. Its shape was elongated, its surface dry and rocky, and it lacked all the hallmarks of a typical comet. This contradiction challenged our understanding of how celestial objects behave. Scientists were left scratching their heads, wondering if they were witnessing something entirely new. What could be pushing Oumuamua if not cometary jets? Was there an unknown force at work, or was our knowledge of physics incomplete? The unexplained acceleration became the central mystery, sparking debates and theories across the scientific community. Some wondered if it was a new kind of natural phenomenon, while others speculated about more exotic explanations. Scientists were forced to consider possibilities far beyond conventional models, ideas that stretched the imagination and challenged the boundaries of what we thought was possible in space. Was it a new kind of natural object or something else entirely? Could it be evidence of processes we have yet to discover, or even something artificial? The anomaly forced astronomers to rethink what's possible in our universe, opening the door to new questions about the nature of interstellar visitors. Oumuamua was not just another interstellar rock. It was a puzzle that refused easy answers, a cosmic enigma that continues to intrigue and baffle. The search for an explanation had only just begun, and the mystery of Oumuamua would inspire a new era of exploration and curiosity about the unknown. Oumuamua's brightness varied dramatically as it tumbled through space, catching astronomers off guard and sparking immediate curiosity. Each time it spun, the amount of sunlight it reflected changed, making it appear to flicker and pulse against the backdrop of the stars. The brightness changed by a factor of 10 every 8 hours, a pattern that was both regular and perplexing, hinting at a highly unusual shape or surface. This suggested an extremely elongated shape, perhaps 10 times longer than it was wide. Imagine a cosmic needle spinning end over end, unlike anything we'd ever tracked before. The initial image was of a cosmic cigar, a slender, reddish object utterly unlike any asteroid or comet we'd ever seen in our solar system. Our solar system's objects are usually lumpy or round, shaped by gravity and collisions over eons, not needle-like or dramatically elongated. Later analysis hinted it might be flat, like a pancake or coin, also unprecedented. This alternative shape only deepened the mystery, as nothing like it had ever been observed drifting through space. Whether cigar or pancake, its shape was truly alien to our catalog of cosmic bodies. It didn't fit any known category, challenging our understanding of how such objects form. The bizarre geometry, combined with its mysterious acceleration as it sped away from the sun, deepened the enigma. It seemed to defy the laws that govern ordinary asteroids and comets. Oumuamua was a riddle wrapped in an enigma, defying all expectations and leaving scientists with more questions than answers. No known process could easily create such an object. Its origin, composition, and even its true shape remained elusive, despite intense study. Its form and motion set it apart from everything we'd ever observed, making it a true outlier in the history of astronomy. The universe had delivered a cosmic oddity, a messenger from the stars, and we were left to wonder why it looked so strange and what secrets it might still be hiding. Oumuamua moved like a comet but looked like an asteroid. No tail, no coma, no visible outgassing. Astronomers searched for chemical signatures and dust clouds but found nothing. Even the Spitzer Space Telescope, sensitive to warm dust, saw only silence. For the observed acceleration, outgassing should have produced a detectable cloud. The lack of a tail forced scientists to imagine exotic compositions, maybe invisible gases or dust too large to reflect light. Each new theory raised more questions than answers. The contrast with the second interstellar visitor, Comet 2Y/Borisov, was stark. Borisov behaved exactly as expected, with a visible coma and tail. Oumuamua, by comparison, was the exception, a true anomaly. Its silence challenged everything we thought we knew about comets. The mystery only deepened as comparisons mounted. Scientists proposed creative natural explanations for Oumuamua's oddities. One idea, a nitrogen iceberg chipped from a Pluto-like exoplanet, could sublimate invisibly and explain the push. Nitrogen gas would be hard to detect, and planetary fragments could be oddly shaped. Another theory, a hydrogen iceberg, but calculations showed it would evaporate long before reaching us. Some suggested Oumuamua was a porous, low-density cosmic dust bunny. Such an object could be pushed by sunlight, solar radiation pressure, without outgassing. But could something so fragile survive a journey through interstellar space? Each hypothesis solved one problem, but created others. No natural explanation fit all the data. The debate over Oumuamua's true nature raged on. Amid the search for natural explanations, Harvard astronomer Avi Loeb proposed a bold idea. Oumuamua might be alien technology. He suggested it could be a light sail, an ultra-thin, flat object propelled by sunlight matching Oumuamua's shape and unexplained acceleration. Loeb argued this fit the data better than exotic natural theories. The claim was controversial, sparking fierce debate. Critics insisted extraordinary claims require extraordinary evidence, and natural explanations should come first. Loeb countered that science must remain open to all possibilities, especially when faced with so many anomalies. His hypothesis reignited the search for techno-signatures and inspired new projects to look for alien artifacts. Theoretical physicist Michio Kaku added his voice to the debate, highlighting Oumuamua's long list of anomalies. Kaku argued that with so many unexplained features, the burden of proof had shifted. Instead of demanding proof of alien origin, he challenged the scientific community to provide a single, coherent, natural explanation. This rhetorical shift legitimized the alien hypothesis as a scientific question, not a fringe idea. Kaku compared Oumuamua to a message in a bottle, an enigma demanding attention. His perspective encouraged open-minded inquiry and kept the mystery alive in public discourse. The conversation about Oumuamua became a test of scientific imagination. In 2019, a second interstellar object, 2I/Borisov, was discovered. Like Oumuamua, it came from beyond the sun's influence. But Borisov behaved exactly like a normal comet. It developed a coma and tail, and its chemistry matched comets from our solar system. Borisov's conventional nature confirmed our theories about interstellar comets. This made Oumuamua's strangeness even more pronounced. If Borisov was typical, what was Oumuamua? The contrast between the two objects highlighted the diversity of interstellar visitors. Borisov reassured us that some things are familiar, even from other stars. Oumuamua remained the wild card, the anomaly. The discovery of Borisov weakened the idea that Oumuamua was just a normal interstellar object. The mystery deepened. Was Oumuamua a rare natural oddity, or something more? The tale of these two visitors left us with more questions than answers. Though Oumuamua is long gone, speeding into the darkness beyond Neptune. We'll never see it again. All we have is the limited data from its brief visit. Scientists will debate its nature for decades, searching for new insights. Oumuamua's legacy is the profound questions it raised, not the answers it gave. It exposed gaps in our understanding and inspired a new urgency to search for interstellar objects. Future observatories will find more visitors, helping us learn if Oumuamua was unique or part of a hidden population. The mystery touches on the ultimate question: are we alone? Whether natural or artificial, Oumuamua expanded our imagination and reminded us how little we know. It was a cosmic hello from the unknown, sparking wonder and debate. The next great discovery could be just a faint speck of light away.